Hello again, and this will be the video on statistics and probability, or probability and statistics. This will be an introduction for the pre-algebra review, just to give a little bit of introduction to some of the concepts and terminology of statistics. So we'll start with statistics, and I'll just cover some of the highlights of the first introduction of statistics. First of all, a capital S statistics means the science of obtaining, calculating, and interpreting data. Now that's with a capital S, okay? With a capital S. Obtaining using surveys or polls, calculating using the formulas, finding the average, mean, median, mode, interpreting data. What does this mean? Does it mean that we've got a valid test? Do we have an invalid test? Do we have a normal curve? Whatever the case may be. Lowercase statistics, well, I'll get to lowercase statistics. When you're dealing with statistics, you're dealing with the population, which is usually the bigger group, and the sample. Sample is a smaller group. A good example of this would be if I took a sample, if I took Anderson County voters and I asked them, who did you vote for on the so-and-so election? And then I used that data to predict a statewide election. The sample would be Anderson County. The population would be the state of South Carolina. Why do we use a small group to predict a big group? Well, those two things that are very valuable to us: time and money. Okay? That's why we use a sample to predict a population. So I might want to find out if I find out that all Anderson County voters, or a lot of 51% of Anderson County voters are going to vote for John Smith for this state or federal, office, then I can use statistics and crank the numbers through and make a prediction for the population, which would be the state of South Carolina. But of course, you need to know more of statistics than just that. You got to know, confidence intervals, confidence levels, margin of error, and all that stuff. But that's later. This is just introductory. Formulas for the population. We use formulas to calculate things for the population, and those variables are called parameters. An example of a parameter for a population would be mu, which is a Greek letter, and sigma, which is a Greek letter, lowercase sigma. Okay, those are parameters. Remember, population starts with a P, and parameter starts with a P. So if you're taking a standardized test or a placement test and they ask you what goes with the population, you say parameter. If they say sample, well, what goes with a sample? Well, sample is where you have the variables for the formulas, lowercase statistic. A lowercase statistic, I can't spell today, a lowercase statistic is the variable used for a sample formula. Lowercase statistic. And it would be like X bar or S for standard deviation. X bar is the average, and S is the standard deviation. Same thing up here. Mu is the average, and standard deviation is sigma. Okay? So S here goes with the S here. So if you're dealing with a population and you're sitting in a presentation and somebody shows you mu is equal to 28, then you know that's the population average age, 28. And then they show you X bar is 27, you know that's the sample because it's the X bar. Okay, so that's one little introductory item that you need to know for statistics is population and sample. Something else you might need to know for statistics is qualitative and quantitative data. Qualitative versus quantitative. Now there's an old saying that says quality, not quantity. Now think about that. I'll write that out to the side. Quality, not quantity. Okay? And that kind of helps you remember what this means. Qualitative data is a category. I like to tell my students blonde, brunettes, and redheads. Okay? Blonde, brunettes, and redheads. Can you tell me how to calculate blondes, brunettes, and redheads in a mathematical calculation? No, you can't, because it's categorical. It's qualitative. Versus quantitative, which means classes, weights, heights, shoe sizes, ages. Anything that's measured in a mathematical form is quantitative. Okay? So category means non-mathematical. Quantitative means, there's supposed to be an N right there. Quantitative, A-N. Okay? Quantitative means classes, means mathematical. Shoe sizes, weights, heights, all that good stuff. What about continuous and discrete? Well, that's the kind of data you're given. Continuous data is something measured. Continuous data is something measured. Continuous data is something measured. Measured means height, weight, volume, area, anything that is measured. That is continuous data. The opposite of continuous data is discrete. Discrete is, and I don't know why I can't spell today, and I don't know why the board is writing all kinds of weird stuff on the board. I'm writing in black and it's putting green, red all over the place. Discrete is counted. Okay, so there's your two definitions of discrete and continuous data. Continuous data is something that's measured. How far did you travel today to come to work or school? Well, one person may say 6 miles, and if they rode in the same car, the other person may say 5 miles. Okay? It's not if I ask you to go outside and measure a fire hydrant, the height of a fire hydrant, and I got 5 people in the class, 5 different people will give me 5 different measurements. Because 1, they don't know how to read a tape measure. 2, they may be sloppy with measurement. 3, they may measure different places on the fire hydrant. From the bottom of where the ground is, some may dig out the ground where it actually touches the water pipe. There's all kinds of different things that could happen when measuring height, weight, volume, area. I'm trying to think of some more, but I can't right now. Discrete is counting. Think of eggs. If I pass around a carton of eggs and asked 5 different students to tell me how many eggs are in that carton, I will get one answer, 12. Because it's counted. If I ask you how many cars are in the parking lot, and I've locked the parking lot where nobody can go in or come in and go out, then we would have a discrete count. Whenever you count something, it's discrete. Whenever you measure something, it's continuous. So make sure you know those definitions. Those are just a few definitions. And again, this is an introductory type review. So it's just, for your information. And I'll show you a few of the calculations that you might want to know before you go into a standardized test or before you go into a, statistics course. Okay, so there's a little bit about those definitions. Let's move toward some basic calculations of statistics. Everybody knows the mean, the median, the mode, the range, the mid-range, and those are basic calculations for your statistics. We don't put in variance and standard deviation. We might do that in Algebra 1 review, but not in this one. Mean, I'm going to give you a sample. We're going to do 20 plus 20, or 20, 20, 21, 22, and 25. There's our data. Okay, let's say they're ages of people in the class. And we want to find out what is the mean, median, mode, range, mid-range, and all that stuff. So, how do you find the mean? Well, you add them all up and divide by 5. Because 5 is n. N is equal to 5. N is equal to 5. There's 5 people in the class. This is x of 1, this is x of 2, this is x of 3, this is x of 4, this is x of 5. If you wanted to call them ages and say ace of 1, ace of 2, ace of 3, ace of 4, ace of 5. Most books use x. Okay, so we're going to sum of x, summation of x over n. So that means that big E right there, that's capital sigma, that's sigma, capital, and that means summation. So whenever you see that, let's highlight that because that's important. Whenever you see this guy, that means add up everything. So I'm going to do it on a calculator. I'm going to show you how to do it on a calculator. But 20 plus 20 plus 21 plus 22 plus 25, all of that over 5. And that's how you find the average. Most of you can do that because you've been figuring your average, test average, since what, the 6th, 7th grade? So most people know how to find the average. The median, how do you find the median? Well, if n is even, you find the average of the 2 middle numbers. And you got to put them in order. Okay? So that means the first number, the middle first number, plus the middle second number over 2. Okay? So you got to find the middle 2 numbers. You add them together and you divide by 2. If n is odd, which in this case n is odd, you just find the middle number. In this case, the middle number is 21. So I'm going to highlight the middle number, and that is because n is odd. N is 5. So just type equals 5. I'm sorry, 21. I don't know why I did that. 21. Mode. Mode stands for which one shows up the most. How do you remember that? You highlight MO and MO. The one that shows up the most. So in this case, 20 is the mode. Now, can you have more than one mode? Yes. You can have monomodal, which means one mode. You can have bimodal, which means 2 modes. You can have trimodal, which means 3 modes. And you can have polymodal, which means more than 3. Okay? If you have no mode, you put does not exist, you put unknown, or there isn't one, or there ain't one. Do not put 0, because some teachers will say there's no 0 in the list and mark it wrong. So don't put 0, put non-applicable, there isn't one, there isn't any, there ain't one, there ain't any, whatever you want to put. Range. Range is the highest minus the lowest. Highest minus the lowest. In this case, 25 minus 20. And that's equal to 4. And then the mid-range is the highest plus the lowest divided by 2. So that's going to be 25 plus 20 divided by 2, which is equal to 45 divided by 2, which is equal to 22.5. Now, that's how you find the basic definitions, the basic numbers for statistics. So, they're not very difficult. And I will tell you this, if your data is pretty tight, if it's really good data, then this number, the mean, the median, and the mid-range will be very similar. I don't know why that red mark is showing up all over the place. I'm sorry about that, but it's showing up for a reason. I don't know why. Let me see if I can delete it. If you have, and I'll erase everything over here, there, I don't know why is it doing that? Okay, anyway, the mean, I don't know what the mean is there, let's figure it right quick, 40, 61, 83, 108, 108 divided by 5, 108 divided by 5 is 2 and 1 and 6, 21.6. I have no idea if that's correct. But if you look at these 3 numbers, let's take a highlighter and highlight in magenta this number and this number, median, and the mid-range. You see that those 3 numbers are pretty close. If those 3 numbers are pretty close, then that means your data is not all over the place. That means it is pretty tight. And that is the basics of statistics. Now, I'm going to move to a little bit of probability. I'm not going to do very much. I'm just going to talk about probability a little bit. Probability is, first of all, I want to try to get rid of this. I don't know why that's here, but it won't go away. So, what is probability? Probability is, I'm going to use a Hubertism definition here. Probability is assigning a number, and I'm going to put a number, but I'm going to put in parentheses a decimal between 0 and 1 on a prediction. And that prediction can be based on logic, experience, or data from statistics. Now that's a pretty general Hubertism definition, but it makes sense. How many times have you gotten behind a slow car on a 2-lane highway that you could not pass, and you got to the end of that highway and it dead ends and you have to turn left or right and you're going to the left, and how many times have you said, I bet this car is going to turn left, and right when you say that, they turn on the left blinker? Okay, does that mean you can tell the future? No, you cannot tell the future. Nobody can tell the future. But we can make educated guesses based off of logic, based off of experience, and based off of mathematics. The probability of an event happening is written like this. That's an E, stands for event. Most of the time, probability is not difficult. The math in probability is not difficult. The problem is students don't read the question. Okay, when I go over probability, I make sure everybody understands. Sometimes the questions even get me because of an is or an and or an or, and you have to be careful when you're reading a problem. But you also have to be careful on what it is they're asking. For instance, if I ask you, what is the probability of heads on a coin? Well, you would say 1/2. Okay, why? Because this is the number of times something happens. Now, this is a Hubertism definition. Something happens over the number of times it could happen. Think about it. How many sides of a coin are there? 2. And one of them is heads. So that is the probability. Now there's 2 types of probability. There is the physical probability that you actually do an experiment or you actually do the event. And then there is what we call the theoretical probability. The theoretical probability is when you don't do the event. I don't have a coin on me right now. So I just did the theoretical probability. Okay? I just did the theoretical probability. Theoretical probability is when you don't have a coin, you don't have a deck of cards, you don't have anything in your hand or your pocket, and you can do the mathematics, but you don't have a deck of cards. Or you don't have a die, or you don't have a coin. And theoretical don't have a H in it. My bad. Theoretical. How about that? So, if I give you a probability and you tell me what the probability is, and you don't have a deck of cards, you don't have a coin, you don't have a die, then that means you're just giving me the theoretical probability. Okay? The theoretical probability is different from the observed. I call it the observed probability because you actually do have a deck of cards or a die or a coin that you actually can flip. So let's do another one. let's do another theoretical probability. What about the probability of a king in a deck of cards? The probability of a king, well, you have to know how many cards are in a deck of cards. You got to know how many kings are in a deck of cards. If you don't know how many cards are in a deck of cards, and you don't know how many kings are in a deck of cards, you can't do the problem. Now, this is a theoretical probability because you don't have a deck of cards in front of you. The probability of a king is 4 out of 52. Because there's 52 cards in a deck of cards. There is 4 kings in a deck of cards. So here, the math is not that hard. You have to know the question. You have to read the question. You have to know the question. And you have to know a little bit about a deck of cards. So the theoretical probability of a king in a deck of cards, picking a king out of a deck of cards, is 4 over 52, which is 1 over 12 or 13. There we go. 1 out of 13. And you can change that to a decimal. How about the probability of a 6 on a die? Well, how many 6s are on a die? 1 die, that's 1. A pair of die is called dice. Okay? A die, there's only 1 6. There's 6 sides. And I think it's repeating 0.16, the 6 repeating. So I've just given you 3 probabilities, and I don't have a coin, I don't have a deck of cards, and I don't have a die. So all 3 of those are what we call theoretical probability versus the observed probability. The observed probability would be if I took a deck of cards, and I had a deck of cards, and I would shuffle the cards, pick a card. Shuffle the cards, pick a card. Shuffle the cards, pick a card. Shuffle a card, pick a card. Let's say I've got a 10, a 2, an ace, a king, a queen. That's 5 cards. Let's do 5 more. A 2, an 8, ace, queen, and a jack. Then I've just picked 10 cards and I got 1 king, so my observed probability of a king is equal to 1 out of 10. Is equal to 0.1. This is not equal. Well, not most of the time. Most of the time, they're not going to be equal, unless it's a coincidence. And that gives us the law of large numbers. What is the law of large numbers? Well, I like to tell students it's kind of a way to make sure you cover your backside as far as working statistics and probability. Law of large numbers. And this is another Hubertism definition. Law of large numbers basically state that if the more observations that you do, the closer the observational probability is going to get closer to the theoretical probability. Okay? The law of large numbers means whenever you do something, make sure you cover your bases and do a lot of observations, because the more observations you attempt, the better off you are. Okay? Let me give you an idea. There was a couple of MIT students that wanted to see, without flipping a coin, how many flips it would take for a coin to reach an observed probability of 0.5. In other words, how many times would it take someone to flip a quarter to get the probability of 0.5? And what they did is they took a roll of quarters and they measured the quarters, they weighed the quarters, they did everything they could possibly do to those quarters, and they got an average virtual quarter. And they took that virtual quarter and plugged it into an algorithm in a computer. They took 40 quarters and they measured them, they measured the balance, they weighed them, they checked the thicknesses, they did everything to the 10,000th or 100,000th place. And then they averaged all those numbers up and they created a virtual quarter in a program. And they took that program and they flipped that quarter until they got 0.5 probability. They flipped that virtual quarter until they got 0.5. And the number of times it took to flip that quarter was almost 100,000 times. 100,000 flips. And it equaled 0.499999 ... or something. It took 100,000 flips for that virtual quarter to reach the theoretical probability of 0.5. Now, what does law of large numbers dictate? Basically this. If you are going to present something when you're in the career, when you're at school, a report, make sure you don't have lazy disorder when you're doing the actual survey, when you're doing the poll, when you're pulling the quality assurance product, when you're pulling the tires or the pills or the CDs or whatever you're pulling, whatever your company is making. Don't skimp on pulling the samples. Don't skimp on, sending out an extra 100 surveys or extra 100 poll. Ask another extra 100 people about this poll, because the more numbers you ask, it's better, and that's what the law of large numbers dictate. Just another little definition. Basically, law of large numbers helps you with your probability and statistics. And let's talk about the complement. The complement basically is what makes up the whole. What do you mean, what makes up the whole, Hubert? Well, when I was in junior high school, lunch was 65 cents. Okay? Lunch was 65 cents. And my mother and father would give me $1. So that was the whole. And the lunch was 65 cents. So what was the change? The change I got back was 35 cents. So 35 is the complement of 0.65. The whole is $1. The reason I use the dollar analogy is because in probability is always equal to 1. So I use the $1 analogy to show you what a complement is. But you can also have a categorical complement. Okay? If everybody in the classroom we have majority is brunette. What is the opposite of brunette? The opposite or the complement of brunette, I don't know how to spell brunette, but I think it's that, is not brunette. What is the complement of true? The opposite of true is not true. Okay? What is the opposite of black? Not black. What is the opposite of white? Not white. So the complement is what makes up. Now let me give you one more. What is the complement? Let's say I got 200 people at work and 150 are not sick, then that means 50 are sick. So you can also do it with a big number too. So the whole is 200. 150 are not sick, so therefore 50 are sick. So a complement is the opposite, or what makes up the whole. Let's give you one more. Success is no success. And my pen just turned into red just by I don't know how it did it, but it did. And I'm going to put success right here, and I'm going to put an X to it. Now, in probability, that's how you do the complement. It's not whatever the other is. Okay, so let me go. The reason I'm giving you the success right here is I'm going to show you how to do odds on the next slide, and that's going to be it for the probability. Okay? So, with that, let's go to the next slide. Let me do the probability of a king, we said, was 4 over 52. Therefore, what is the complement of drawing a king? Not drawing a king. So I'm going to put P, and then I'm going to put a K, and then I'm going to take a red marker, and I'm going to put an X through it, because that means not a king. And you need to think, whenever you're in probability, you need to think about the opposite of this is not this. And that's the way you need to do that. Now, let's talk about success. If we said that we're trying to pull a king out of a deck of cards, then that means this up here is success. If this has got an X through it, then that means that this is not success. Some people might even call it failure. Okay? So this is the probability of success. This is the probability of failure. So what is the complement of 4 to 52? That would be 48 to 52. Simple math. Now, I'm going to give you the two formulas for odds against and odds in favor. Odds against is the probability of failure over the probability of success. And the odds in favor is the reciprocal. Probability of success over the probability of failure. But once you find one, you know the other because it's just flip-flop. Okay, I focus on the odds against because that's most gambling questions that you're asked. That's the ones that they usually ask for. So, when you do the odds against, you want to leave your probabilities in fraction form because it's easier to do the math. So in this case, the probability of failure is 48 over 52. The probability of success is 4 over 52. When you divide by a fraction, you multiply by the reciprocal. And the 52s cancel, and you're left with 48 over 4. That can also be written 48 to 4 and 48 to 4. Now it can be reduced also. So your final answer would be 12 to 1. I don't know why that is there. 12 to 1 or 12 to 1 or 12 to 1. That's your final answer, and you can write it one of those three ways. the directions may tell you how to write it. That's how you find the probability, and that's how you find the odds against. So I'm going to do one more for you, so you'll know how to find the probability. Because the reason I didn't do two of the averages is because most people can do those because they've been doing averages for about 6 to 8 years after the 6th grade. So most people can do those. Okay? So here we go. What is the probability of getting an even number on a die? And of course, that's success. So failure would be the probability of not getting an even number on a die. So how many even numbers are on a die? 2, 4, and 6. So that's going to be 3 over 6 or 1 over 2. And you always use the reduced form. So we're going to use 1 over 2. So what is the probability? What is the complement? The complement is 3 over 6. Because there's 3 that are not even. There's the 1, there's the 3, and there's the 5. So that's going to be 1 over 2. And in this case, the probability, the odds against, is 1 to 1 because you've got these two, and that's going to be 1/2 over probability of failure over the probability of success, which is 1/2, and multiply by 2 over 1, you get 1. So your odds against is 1 to 1. And that's how you find that. And that's how you find the odds against. And that's a little taste of probability and statistics for your pre-algebra review.